Hello again, everyone. Today I'm going to be discussing Integrated Math 2's Practice 3. We're working on linear and nonlinear functions where we are multiplying and factoring. Starting with number 1, anytime you see a number outside of parentheses, it has to go inside and multiply whichever terms are in there. 2 times x makes 2x. 2 times a positive 5 is a positive 10. In the second one, notice that the outside number is 3y. When 3y goes into the parentheses and multiplies y squared, that's going to become 3y to the third power. The reason being is because when you're multiplying, exponents will add. And while we don't see an exponent on the y outside, that exponent is understood to be a 1. So 1 and 2 make y to the third. When 3y multiplies positive 4, we get positive 12y. Number 3, we have 4a squared b going into the parentheses to multiply each term in there, starting with 3ab to the third. 4 times 3 makes 12. A to the second and a to the first make a to the third. B to the first and b to the third add up to b to the fourth. When we multiply the next term, 4 times negative 6 is negative 24. A to the second, a to the first is a to the third. B comes over here and sees no other b's in this expression, so it's just going to stay b. When 4a squared b multiplies the last term, 4 times a positive 2 is a positive 8. A to the second finds no other a's in this term, so it just stays a to the second. And b to the first hooks up with b to the second to become b to the third power. Negative 3x times x to the fifth minus y. When negative 3x multiplies x to the fifth, it becomes negative 3x to the power of 6, because this 1 and these 5 add up to make 6. When negative 3x multiplies negative y, a negative times a negative becomes positive, and since these are not the same letter, we just write them both down side by side. We get positive 3xy. The next section, we're asked to factor. Here we have 6x minus 15. I'm looking to see what the GCF of the terms that are out there might equal. So between 6 and 15, I'm trying to think, what is the largest number that will divide both of those? Well, that number happens to be 3. So I write the 3 down, and then I open up a parentheses beside it. And now I have to ask myself, what would 3 have to multiply? The same way that 2 multiplied up here. What would it have to multiply in this parentheses to turn back into 6x minus 15? 3 times what is 6x? 2x. 3 times what would make a negative 15? A negative 5. For number 6, the coefficients 5 and 10, the GCF is 5. That's the biggest number that divides them both. And these guys both also have a common letter. If they have a common letter, you can use it on the outside where the GCF is. They both have a y, so I'm going to write down that y. And the exponent I choose has to be the smallest exponent that's out there. So between 3 and 2, that is a power of 2, smallest exponent. I open up my parentheses and ask myself, 5y squared times what would make a 5y to the third? All I need is another y, so that y2 and y1 will make y3. 5y squared would multiply what to become 10y squared? I would need a positive 2 to make 5 times 2, 10. But I don't need any more y's because I already have enough on the outside. There are 2 out here, 2 here, so I am done. Number 7, 6, 4, and 12. The GCF, the biggest number that can divide them all, is 2. They all have a common letter of A, and the smallest A is A2. They all have a common letter of B. The smallest B is B1. Now I open up parentheses, and I figure out what goes inside. 2 times what would make the 6? 3. A to the second becomes A to the fifth. So I need 3 more A's for that to happen, so that 2 plus 3 will make 5. I've got B to the first here and B to the first in this term. I don't need any more B's for term 1. 2a squared b times what would be 4? A to the third, b to the fifth. I need 2 times a positive 2 to make this positive 4. A to the second needs 1 more a to become a to the third. B to the first becomes b to the fifth, so I need 4 more b's. Finally, 2 times negative 6 would make a negative 12. A to the second is already A to the second, so I don't need any more A's, but a B to the first turns into B to the second. I need one more B for that. Number 8, I've got positive 12 and 4. GCF would be 4. They have a common letter variable in x, and the smallest exponent of x is 3. But they both don't have a y. If each term does not have that letter, I can't use it for the outside number. Now I open up parentheses. 4 times what would make 12? 4 times 3 is 12. X to the third becomes x to the 6, so I need 3 more x's. 4 times what will make a negative 4? Negative 1. X to the third is already x to the third, but I do need both of those y squareds in here, like so. Moving down to the next section, we're asked to multiply. These are called binomials. They each have 2 terms. When you multiply, you start with the first term of the first parentheses times the first term of the second parentheses. So that would be x times x in this situation. That makes x squared. X times a positive 6 is a positive 6x. Now it's 2's turn to do the exact same thing, to multiply both terms. 2 times x is 2x. And 2 times 6 is 12. Most times you will find like terms in the middle. 6x and 2x can combine, because they're like terms, to make 8x. So we end up with x squared plus 8x plus 12. Number 10, y times y would be y squared. Y times negative 5 is negative 5y. Negative 4 times y is negative 4y, and negative 4 times negative 5 is a positive 20. Negative 5y and negative 4y combine in the middle to make negative 9y. Whoops. So I get y squared minus 9y plus 20. Number 11, a times a squared. A times negative 4, negative 4a. Positive 11 times a, positive 11a, and positive 11 times a negative 4 is a negative 44. Negative 4a, positive 11a are like terms in the middle. If you combine them, you will get a positive 7a, so we end up with a squared plus 7a minus 44. Number 12, 2x times 4x would be 8x squared. 2x times a negative 1 is a negative 2x. Negative 3 times 4x is a negative 12x. Negative 3 times negative 1 is a positive 3. 2 terms in the middle are like terms. They combine and they will give us negative 14x in the middle. Last section, again it says to factor. We're doing the exact reverse of what we did up here. Notice that the answer is what we call a quadratic trinomial. So are these. So our job is now to figure out which 2 binomials multiplied to make them. So I start by drawing 2 parentheses. And to get x squared, that first term, that was easy. That had to have been x times x. The same way it's x times x up here to give us x squared. But to get the number 28, well, that could have been a few things. It could have been 1 times 28, or 2 times 14 makes 28. And so does 4 times 7. How do I know which of these to choose to put in here? I have to now look at my middle number. Not only do these numbers need to multiply to make the back number, but they also need to either add or subtract to make the middle. And I noticed that 4 and 7, if you were to subtract those, you would end up with a 3. So 4 and 7 are my numbers. When I want to think of the signs, I think of what kind of 3 is this in the middle? It is a negative 3. What kind of 4 and what kind of 7 would combine to make a negative 3? That would require a positive 4 with a negative 7. Those 2 together would make negative 3. X squared plus 12x plus 36, 2 parentheses, x and x. 2 numbers that multiply to make 36 and then combine to make a 12 would be 6 and 6. It's a positive 12, so both of these 6's need to be positive in order for that to work. Numbers 15 and 16. 15, I'm going to open up my 2 parentheses, and I have y and y. Two numbers that multiply to make 16 and combine to make a negative 10 would be 2 and 8. And they would both have to be negative. Negative 2 and negative 8 would make negative 10y in the middle. 16 is a little more challenging because it has a leading coefficient of 2. What I'd really like to happen is if every single term can be divided by 2, that's what I want to do first. I would like to factor out that 2. 2 times what would be 2a squared and a squared. 2 times what would be a positive 10a, positive 5a. And 2 times what would make negative 28, negative 14. Now, the inside trinomial is like these others we've been doing. You gotta leave the 2 there, but you can now open up your 2 parentheses. A squared would be a times a. And 2 numbers that multiply to make 14 but can give me a 5 would be 2 and 7. It's a positive 5, so I need this to be positive 7 and negative 2 in order to get a positive 5. All right, so that takes care of the front side. Tune in for part 2, and you'll see the back side.